a proton and a proton. I consider two protons. They act only for a certain short range. Between two protons is 100 times stronger ratio of the difference between the atomic mass. One is acting up, the other one is acting down. Hello students, let us continue our discussion on nuclei. In today's class, we study a classical concept called nuclear forces, the properties of nuclear forces, and then we will expose ourselves to the phenomenon of radioactivity. So to begin with, let us start understanding a concept that is trivially asked for 1 mark in the examination, something called as packing fraction. Now, in yesterday's class, we studied the characteristics of a binding energy curve, and we understood how the curve accounted for the stability of the nuclei. We told iron nuclei in between mass number 60 to 140, they are more stable because they have high specific binding energy. Nuclei whose mass number is greater than 180, they are considered to be radioactive. Stability is less. Here today, another concept which will give the stability of a nuclei and hence stability of an atom. Now, packing fraction is defined as a ratio. It is the ratio of the difference between ratio of the difference between the atomic mass, ratio of the difference between the atomic mass of the atom and its mass number is what we call as packing fraction. Therefore, F, which is packing fraction, is defined as M minus A, atomic mass difference the mass number to the mass number ratio is called packing fraction. But now this is important. All nuclei having negative packing fraction, the nuclei which has negative packing fraction are more stable in nature. A classical 1 mark question, if the packing fraction of a nucleus turns out to be negative, it is considered to be more stable. So more negative is the packing fraction of a nuclei. It is considered to be more stable. Now let us understand the beautiful topic called nuclear forces, the meaning of nuclear forces and its characteristics, which is asked for 3 marks very evidently in the exam. What is nuclear force? And what are the properties of nuclear forces? The general characteristics of nuclear forces is what we study epically in today's class. Now, when I gave the picture of the nuclei, we told the protons and neutrons, the so-called constituent particles, are present inside this nuclei. My dear students, there is a force which keeps these particles binded within the nucleus, a kind of force which is governing the presence of nucleons inside the nucleus. Classally, teacher ಅನ್ನೋ ಫೋರ್ಸು ಸ್ಟೂಡೆಂಟ್ಸ್ ಅನ್ನೋ ಕಾನ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ನ ಕ್ಲಾಸ್ ಅನ್ನೋ ನ್ಯೂಕ್ಲಿಯಸ್ ಒಳಗೆ ಇಟ್ಟಿರ್ತಾರೆ. ಅದೇ ರೀತಿಯಾಗಿ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಲ್ಲಿ ಒಂದು ಗವರ್ನಿಂಗ್ ಫೋರ್ಸ್ ಇರುತ್ತೆ, ಅಡ್ಮಿನಿಸ್ಟರಿಂಗ್ ಫೋರ್ಸ್ ಇರುತ್ತೆ. ಆ ಫೋರ್ಸ್ ಏನ್ ಮಾಡುತ್ತೆ? ನ್ಯೂಕ್ಲಿಯಾನ್ಸ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಒಳಗಡೆ ಗಟ್ಟಿಯಾಗಿ ತಡೆ ಹಿಡ್ಕೊಂಡಿರುತ್ತೆ. ಅಂಡ್ ದ್ಯಾಟ್ ಫೋರ್ಸ್ is what I call nuclear force. So what is nuclear force, my dear students? In a nucleus, the nucleons are bound. They are held together by strong attractive forces. ಸ್ವಲ್ಪ ಆ ಪದದ ಮೇಲೆ ಗಮನ ಹರಿಸಿ. They are bound or held by strong attractive forces, and these forces are called nuclear forces. So when I try to understand what is a nuclear force, they are strong and attractive in nature. Again, I repeat these two words: strong, attractive forces in nature. What do? They keep the nucleons bounded inside the nucleus. They hold the nucleons inside the nucleus. Therefore, they are called nuclear forces. Now, we shall try to understand the properties of nuclear forces. The very first property says nuclear forces are the strongest forces in nature. You have studied the 4 basic forces: gravitational force, strong nuclear force, weak nuclear force, electromagnetic force. We say nuclear forces are the strongest forces in nature. Here I have an ambiguity, a question mark. Very much before I told, nuclear forces are strong as well as attractive forces. Mention marde alva? Nuclear forces are strong and attractive forces. Now, I consider a nucleus where I have a proton and a proton. I consider 2 protons, positively charged particles, like charges. My elementary physics told wherever there is like charges, they are repulsive in nature. ಎರಡು like charge idre force between them has to be repulsive. But I am calling nuclear force between 2 protons as strong and attractive. Has my elementary law broken down? No. Understand, students, there may be 2 protons or 2 neutrons. Here in this case, consider 2 protons. There will be repulsion between them. The basic nature of the law cannot be questioned. There will be repulsion between these 2 protons, but the nuclear force between them is 100 times stronger than that repulsive force. The magnitude of the nuclear force between 2 protons is 100 times stronger than the repulsion between them. Andre, yes, repulsion happens, but the nuclear forces are so strong that they will damp the effect of repulsion. And that is why the protons stay inside the nucleus rather than coming out. So please to know, nuclear forces between 2 protons is 100 times stronger than the repulsion between them. And the nuclear force between any 2 nucleons, maybe 2 protons, 2 neutrons, a proton and a neutron, is 10 power 38 times stronger than the weakest force in nature, that is gravitational force. Therefore, we say nuclear forces are the strongest forces in nature. So, please to understand, the nuclear force between 2 protons is 100 times stronger than the repulsion between them, and the same nuclear force between two protons or two neutrons is 10 power 38 times stronger than the gravitational force between them. Hence, nuclear forces are the strongest forces in nature. Next one. Nuclear forces are short-ranged forces. What do you mean by that? Short-ranged forces. Again, if you observe a proton and a neutron, proton and a proton, neutron and a neutron. Now I say, this proton can interact with its immediate neighbor. This neutron can interact with its immediate particle. Andre, nuclear forces between any two nucleons exist when they are separated only by a distance of 2 Fermi. Very important. The magnitude of the nuclear forces are appreciable. The existence of nuclear forces between two nucleons is seen when they are separated by a distance of 2 Fermi. Above 2 Fermi, nuclear forces start to die. Andre, their effect starts to decrease. Therefore, they are called short-ranged forces. They act only for a certain short range, for a certain small distance. And what is that distance? Appreciable only when the nucleons are separated by 2 Fermi distance. Above 2 Fermi distance, the effect of nuclear forces starts decreasing. They become saturated. Now, very important, nuclear forces are charge independent forces, which means, suppose I consider 2 protons, 2 neutrons, a proton and a neutron. Among this combination, which of them will have maximum nuclear force? Is it the 2 protons? Is it the 2 neutrons? Is it the proton and the neutron? Which of them will have maximum nuclear force? My dear students, nuclear forces do not depend upon the charge of the interacting nucleons. All these 3 combinations have the same magnitude of the nuclear force. 2 ಪ್ರೋಟಾನ್ಗಳಾಗಿರಬಹುದು, 2 ನ್ಯೂಟ್ರಾನ್ಗಳಾಗಿರಬಹುದು, ಒಂದು ಪ್ರೋಟಾನ್ ಮತ್ತಿನ್ನೊಂದು ನ್ಯೂಟ್ರಾನ್ ಆಗಿರಬಹುದು. ಇವುಗಳ ಮಧ್ಯೆ ಸೇಮ್ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ನ್ಯೂಕ್ಲಿಯರ್ ಫೋರ್ಸ್ ಇರುತ್ತೆ. ನ್ಯೂಕ್ಲಿಯರ್ ಫೋರ್ಸ್ ಚಾರ್ಜ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರಲ್ಲ. ಬಟ್ until these particles are separated by 2 Fermi distance, only when the interacting particles are separated by 2 Fermi distance, I told nuclear forces are appreciable. Above 2 Fermi, magnitude goes on decreasing. So please to understand, nuclear forces do not depend upon the charge of the interacting nucleons. Any combination of the given nucleons, until they are separated by 2 Fermi distance, will have the same magnitude of nuclear force. Then what does nuclear force depend upon? Spin. So, depends upon the spin, something called as spin of the nucleons. If I draw 2 parallel lines, this means the nucleons have parallel spin, and this is anti-parallel spin. The magnitude of nuclear forces will be maximum if the nucleus has parallel spin. If the nucleons have this spin condition, both of their spins act in the same direction, parallel spin, then the nuclear forces is maximum. If this is their spin condition, one is acting up, the other one is acting down, what you call anti-parallel spin, nuclear force becomes minimum. What is important here is nuclear forces are charge independent, whereas they depend upon the spin. Nuclear forces are exchange forces. Andre, if nuclear forces have to exist, something has to be exchanged. Andre, if I have a proton and a neutron, only when an antiparticle called pi meson and elementary particle called pi meson is exchanged between them, only then nuclear forces come into picture. Any 2 interacting nucleons, if nuclear forces have to pitch in, there has to be an exchange of pi meson, and finally we say nuclear forces are non-central. So these are the properties of nuclear forces. Very beautiful. So we have understood what is a nuclear force in depth. We have understood what is the properties of nuclear forces. Now, continuing further, we will have an introduction to the phenomenon of radioactivity. My specific binding energy curve showed all nuclei whose mass number is greater than 160, they are less stable, and those elements are called radioactive elements. Now, what is this phenomenon of radioactivity? What do I mean by radioactivity? It is a phenomenon of spontaneous disintegration. In disintegration andre, the meaning of disintegration is decay or breakdown. Kolthogodu. When an animal is dead, the body disintegrates, decays, or very skeletally it means breaks down. Spontaneous disintegration, ಯಾವುದೇ ಎಕ್ಸ್ಟರ್ನಲ್ ಫ್ಯಾಕ್ಟರ್ ಬೇಡ, ತಾನಾಗೆ ಡಿಸಿಂಟಿಗ್ರೇಟ್ ಆಗುತ್ತೆ, ತಾನಾಗೆ ಡಿಕೆ ಆಗುತ್ತೆ. It is the spontaneous disintegration of the nucleus of an heavy element. Very careful. Nucleus of heavy elements. Lighter nuclei alla mass number should be greater than 160. By emitting certain radiations, so that disintegration, the heavy nuclei, heavy element breaks down, decays or disintegrates by emitting certain radiations. And this phenomenon is called radioactivity, emission of radiations. Activity by emitting radiations. What is that activity? Disintegration, spontaneous, self-triggered, without external aid. Spontaneous disintegration of the nucleus of an heavy element. How? By emitting certain radiations is called radioactivity. And this activity found in elements whose atomic number ranges from 83 to 92 are called natural radioactivity. This is the atomic number. Elements which have atomic number in between 83 to 92, they are naturally radioactive. And the radiations emitted may be alpha rays, beta rays, or gamma rays. Understand, either an alpha ray may be emitted, or a beta ray, or a gamma ray, but all the three rays cannot be emitted in succession. So this is what is called radioactivity. Now I have a small assignment for you all. I want you all to take down a book, a pencil, and jot down the properties of alpha rays, beta rays, and gamma rays. In my next session, students, I will come up with a very important law called radioactive decay law. Until then, have a nice time. Thank you.